Dear student, welcome to my channel. Topic of this video is Euler's Totient function phi of n. Now let us start. The Euler Totient function phi of n counts the number of integers from 1 to n that are relatively prime to n. That is, integers that share no common factors with n other than 1. Now we'll see the procedure. So when n is prime number, then phi of n is equal to n minus 1. All integers less than n are relatively prime to n. When n can be factorized into different prime factors, then at that time we can calculate the Euler Totient function as n, that is original number n, into 1 minus 1 of p1 into 1 minus 1 of p2 dash 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 up to 1 minus 1 of pk. Now we will see the example to understand the concept. First we will see the n equal to 10. Now when you take the prime factors of n, that is prime factor is nothing but all factors are prime. So 2 into 5, so where 2 is also prime, 5 is also prime. Phi of 10 is equal to 10 into 1 minus 1 by 2 into 1 minus 1 by 5. So here we are getting, after calculation, number 4. So 4 numbers are relatively prime for n number, and they are 1. So because the 10 and 1 are co-prime to each other, because their GCD is 1. 10 and 3, their GCD is 1. 10 and 7, their GCD is 1, and 10 and 9, their GCD is 1. All other remaining numbers will not come, like 2, because 2 and 10, 2 is common. 10 and 4, 2 is common. 6 and 10, 2 is common, and 10 and 8, 2 is common. So relatively prime numbers are 1, 3, 7, 9. So in Euler Totient function, we require to just find out this number, that is nothing but 4. Now we see the next example, n equal to 7. When n equal to 7 are there, then phi of n is equal to n minus 1, and we can see that from 1 to 6 all numbers are co-prime, or their GCD with respect to 7 is 1. So when n is prime, we can directly calculate phi of n is equal to n minus 1. Now we'll see the next example, n equal to 12. So prime factors of 12 is 2 into 2 into 3. So this factor we not take twice in the calculation because it is repeated. So phi of 12 is equal to 12 into 1 minus 1 by 2, that is this factor, into 1 minus 1 by 3. So after calculation we are getting the number 4, and we can check that this 1, 5, 7, 11, these numbers are co-prime to 12. So when we take the GCD of this number with respect to 12, the GCD is 1. Next, n equal to 15. Prime factors for 15 are 3 into 5. Then phi of 15 is equal to original number into 1 minus 1 by their factors. So 1 by 3 and 1 minus 1 by 5. So total values are 8. So relatively prime numbers with respect to 15 are 1, 2, 4, 7, 8, 11, 13 and 14. Next we will take n equal to 20. So 20 factors are 2, 2 into 5. So only 2 prime factors are 2 and 5 are there. So we'll get the 8 number, that is phi of 20 is equal to 8. So relatively prime numbers are these numbers, so GCD of this number with respect to 20 is always 1. Next is equal to n equal to 18. So prime factors are basically 2 and 3. Number is 18. So after the calculation we are getting the 6. So all these 6 numbers are relatively prime with respect to 18. N equal to 25. So that is nothing but 5 into 5. We will take prime factor 5 only, because we will not take the repeat numbers. So we will get the 20. So relative prime numbers for 25 are 20 numbers. So only 5 will be skipped, 10, 15 and 20 will be skipped. So in this way we can calculate the Euler's Totient function. You can see some of the exercises and try. So for prime numbers you can directly write down n minus 1. but for others you require to do the calculation. So this is all about Euler's Totient function. So these are the sub steps when we are calculating the, or when we are applying the cryptographic different functions. So in the next lecture I am going to explain the modular arithmetic and then Fermat theorem and Euler theorem respectively. Thank you.